Okay, so now I'll be doing binary search. Um, it is taught in school, but I have not done it like in a while, ever since I have graduated. So yeah, let me look at what. So given an array of integer nums, which is sorted in an ascending order. Okay, so I guess ascending is quite important. An integer target, write a function to search for a target in number. If target exists, return an index, so the position. Otherwise, we return -1. So if it doesn't exist, return negative, right? Okay. Okay, so this is the key problem. Um, of course, how I would solve this kind of situation, this kind of problems is, I'll start with a brute force solution. So brute force. So of course you can solve this question with a loop. Solve with a loop. So for example, we do for integer I equals 0, I less than nums.name, I increment. So we will check and keep looping if um, nums I is equals to target, return I. Else we will return -1. Okay, let's see. If worst come to worst, we can always use the brute force method. So yeah, of course, um, we are not following the rules, right? In this case, because it's a normal for loop that goes from the start to the end, in a worst case scenario, we will have a time complexity of O to the power of n. Because let's say 9 is at the back, or even if we don't have a number, um, it will loop through the whole array, causing O to the power of n. So that's why we need a binary search. So yeah, let's consider solve. Okay, so how does binary search work? If I remember correctly, let's see, 0, 1, 2, 3, 4. Okay. So if I remember correctly, binary search can only be done in a sorted array. And in our case, we are lucky to have a sorted an array that is sorted and in an ascending order. So how binary search is, it's similar to how pointers work. We pick a point, the start and the end point. Then we will pick a middle point. And if we use integer, so integer have this property. If you get an index number, say 2.5, it will concatenate to it will be concatenated, so it will only take concatenated, so it becomes 2, right? So if I have an array of even numbers, I'll take the item 1, the index 1, sum the last index. This will give me 0, 1, 2, 3, 4, 5, 5 in total, 0 plus 5, and I'll divide by 2, right? I want to find the middle point. So the middle point is 2.5, but we use integer, so we are forcing it down here. M stands for middle point, right? And then remember we have t, say maybe t will be 3. And then we take the middle point, we compare it. If it becomes t, we can just return the position of the middle point. But if it doesn't become t, we'll have to see if it's bigger or smaller. So what I mean by that is, if the item at the midpoint 1 is bigger than 3, no, 1 is smaller than 3. So that means my target is somewhere on the right side of the array. right? Because it's already sorted. So that's the keyword. So what happened here is I will move this. I'll move this arrow to be this item. And then I will use +1. Move this here. So this will be my new output. Right? So you can imagine we use a for loop. Okay. Then we use the search for midpoint again, which is here. This is our new midpoint. And this time our midpoint is equals to our t. So in this situation, I would return the midpoint, which is 3, I believe, 0, 1, 2, 3, 4, 4. The midpoint will be 4. So it'll be index 4. Yeah. So I guess that's how I would solve this solution. Let me try to write it out. Yeah. Okay. So integer n equals to nums.length. Okay. On the left and right pointer, right? Integer left is equals to 0. It starts off as 0, and right will be n minus 1. It will be the last item. Right? While left is less than right, then okay. If left, oh, I was gonna write if left is equals to right. That means it doesn't exist. The midpoint doesn't exist. Then we will return -1. But it's the same here. Okay. We will have a return -1. So how do we convert what we just said into code? So we want a midpoint. Maybe we can create a midpoint. This equals to left plus right divided by 2. Is equals to, oh sorry, if nums midpoint is equals to target, return midpoint. Nothing's wrong with this. Else, okay, so now this is a tricky one, I guess. Nums midpoint is bigger than target. We do something else. If it's smaller, we do something else. Okay. So if it's bigger, right? So if it's the number in the midpoint is bigger than the target, we want to move the right to be the midpoint. Right will be equals to midpoint plus 1. Okay, b minus 1. Else left would be our midpoint increment by 1. Right. Okay. I guess let me try this solution. Okay, so let's see what's wrong. Well, time limit exceeded. Okay, I think I know what's wrong. Midpoint is equals to plus right by 2. give it a moment. Yeah, so I guess I'm on the right track. Output expected 1. Let me see. Where could I have gone wrong? Left is less than, right? Okay, so remember the concatenation. Um, if I start off at 0 and the index is 1, the right is 1, 0 plus 1 will give me 1, divided by 2, I get 0.5. And if I concatenate, it's 0. So meaning, are we not supposed to use the midpoint? If the numbers on the midpoint, which in this case is 2, is equals target, which is not, then we go through here. I guess, wait, something like this? Wait, I don't want to just code meaningless. So if the number is more than the target, in this case, no, it's less than, then we want to move left, equals to midpoint plus 1. And then because midpoint is 0, we will hit this condition and it will return -1. Numbers. I feel like it should work though. This. Oh, what? Okay, so let me see. And the first round is 0, 1. Okay, so I'm trying to run it through my mind. How this works, right? Go back to so this will be equals to 0, right? So if nums midpoint nums 0 is equals target, which is no, um, because it's 0 that's not equals to 2, so it goes to here. um, 0 is more, no, so 0 is less, true. Then your left will be 0 plus 1, right? Equals to midpoint, which is, remember, the midpoint is 0 plus 1. Okay, then so now your left is 1. 1 is less than or equals to 1, which is true. Now I'm a bit confused. I'll need to check with ChatGPT. Um, equals to okay, sorry, I got really confused there. So basically, um, less than, less than or equals to, that means if this is 1 and this is 1, the left is equals to 1 and right is still equals to 1, we will still be able to run this sequence. Oh, okay, that was embarrassing. So, but yeah, so that is how, I guess I didn't really solve it myself. I had to reference um, ChatGPT or Gemini in this case for learning materials. But yeah, that's my basically how I solve binary search. Thank you for watching.